This is part 1 of a 3-part series of videos on research intended for both undergraduate and postgraduate medical professionals interested in carrying out research as part of their professional development.
Welcome to another episode of the TheSynapse e-learning series. With us today we have Prof. Liberato Camilleri, who has kindly joined us to discuss sampling methods in scientific research. Prof. Liberato Camilleri is the head of the Department of Statistics and Operational Research within the University of Malta. Thank you for accepting to be here with us, Prof.
Thank you for the invitation.
So we know that scientific research is at the forefront of any new innovation, whatever the profession may be. And as part of our e-learning series, we wish to produce a number of interviews which will help both the student and the professional in performing research professionally with good results. So today we'll be speaking about sampling methods, and in fact scientific research is quite important, and sampling is also an important process prior to starting research.
It is.
What can you tell us? What is a sample in basic terms?
So normally when we carry out a study, we never target the whole population. Why? Because the population is sometimes extremely large. Sometimes we don't even know the population size, and we can never target the whole population because very often it is unfeasible. So what we normally do is we select a sample, okay, which is a subset of the population. And then from the sample, we try to make inference about the population. Inference means generalizations, conclusions about the populations. Now, to have a very good sample, it is important to keep in mind that, first of all, the sample size must be adequately large, okay? It must be a true representation of the population, and it must be selected randomly, okay? If one of these features is not satisfied, it is very likely that the sample is not a true representation of the population. Now, what do we do when we select a sample? Once we select a sample, we measure some sample statistics, for example, like the sample mean, sample standard deviation, sample proportion. And then using probability theory, we can make inferences about the population values, okay? For example, if I find in a study that 8% of students in secondary schools are dyslexic, okay? Then I can use probability theory to make inference about the actual population proportion. And I may deduce that, for example, the actual proportion of students who are dyslexic ranges, for example, between 5% and 8%, okay? And that is one way of making inferences.
And in fact, I wanted to ask more about this. There are two types of sampling, you know? There's probability and non-probability sampling. What is the main difference between them, and when do we use one or the other?
Now, in probability sampling, you assume that each member within the population has equal chance of being selected, okay? So what we do, we allocate a number to each individual within the population, and then using a random number generator, the generator will give us a set of randomly selected numbers, and from these numbers we can identify the sample. That is truly random, and that is highly recommended. Unfortunately, this random sampling or probability sampling is never or hardly ever used. Very often, when we have populations which are very large, okay, or are infinitely large, we cannot use probability sampling. Even when we do studies in Malta, where we are considered to be a very, very small population, random sampling is extremely difficult to carry out because this population is changing continuously. People are dying, people are migrating. So using random sampling can only be carried out when the population size is finite, is rather small. And I have all the information about the members within the population. Now, most of the times when we carry out statistical analysis, we will be using non-probability sampling. Okay, there are various sampling techniques like, for example, cluster sampling, stratified sampling, systematic sampling, convenience sampling, snowball sampling, in which the researcher subjectively make his own judgment in selecting the sample. Now you may ask, but is it truly random? Very often, most samples are random or close to random. These methods are accepted in statistics and people can use them in research.
So let me just summarize to make sure that everyone understands. If we have a village of, for example, 1,000 citizens and we need to conduct a study, we can either choose to pick up everyone, randomly and indifferent of what their characteristics may be, or since some of the citizens may migrate, we may choose to a different category, a smaller portion, in which case it would be non-random sampling.
Exactly. Let me describe some of the non-random sampling, non-probability sampling methods. For example, in systematic sampling, you select people by identifying by choosing them sequentially. For example, every 10th door, okay, I submit a questionnaire, okay, give it to a family member, and the family member will give me the feedback on a written questionnaire. For example, I may use stratified sampling. For example, I know that in any population, the proportion of males and females in that particular population are equal. So I make sure that, for example, the number of males and females in my sample are equal or approximately comparable. For example, if I'm doing a study about university students, I know that for every 2 males attending university, there are 3 females. So I make sure that my sample is stratified according to the population. For example, if I'm conducting a poll before an election, very often I use stratified sampling. For example, I know that the people living in each district are comparable. So if I stratify my sample by district and gender, for example, I must take into consideration that I have equal number of males and females from each district.
And there's no limit to the stratification criteria which you may adopt, no? So it's age, sex, locality, whatever.
Exactly. But you have to be very, very careful, because the more stratification factor you include, the more difficult it is to find the appropriate sample. Normally, I use 2 stratification factors, and very often I use stratification factors which can be measured. For example, using socio-economic status as a stratification factor is quite difficult, because it is very difficult to identify the people with low, middle and high socio-economic status. So normally socio-economic status I don't include as one of my stratification factors, but I can include gender, age groups. Those are easy to categorize.
And from your professional perspective, given that, for example, I finished the research and you're going to criticize it constructively to make sure that it is a veritable research which starts from point A to point B, for example, with logical coherence. What are the main errors which you commonly find in the research which you analyze?
Normally, when I review research carried out by researchers, sometimes you find flaws in their research. One of the flaws would be that very often they don't identify the population. So the first thing that you have to do is identify the population, your population. Who are your participants? Are they people? Are they components? Are they items? Are they teachers? Are they workers? Are they pensioners? So you have to specify what your population is. Secondly, you have to specify the sampling method. Okay, as I mentioned before, there are a number of sampling methods. The most widely used, in my opinion, is stratified sampling and perhaps systematic sampling, although random sampling is the most recommended. Then you have to specify a sample size. Before you carry out a study, you have to identify a sample size and comment on the margin of error. Now, when we comment on the margin of error, when we identify a sample size and calculate the margin of error, the smaller the margin of error, the better. Okay? However, there is a problem, because if I try to reduce the margin of error too much, the required sample size will be large. Okay? For example, if I decide to choose a margin of error of 1%, I require a sample of around 10,000 participants. With 2% margin of error, then my sample size will be around 2,500. Okay? So normally every researcher has to trade off between not having a very small sample size that make his study not powerful, not robust, and not having a large margin of error, okay, which reduces the power of your analysis.
To access more information about this topic, because this topic is an essential one if you're conducting research, and it's better if you prepare yourself before you start your own methodology. So where should one access more reliable information about this topic?
Nowadays, there are several good books about statistics, and even if you search the internet, you find a lot about sampling methodologies. In fact, I brought with me one of the books which I highly recommend to my students at university, because this book not only is called Modern Elementary Statistics, written by John Freund. This book not only explains sampling methods very well, but it also deals with probability problems and sampling methodologies and statistical inference. It also shows how statistical analysis is carried out with very good, specific, pragmatic examples. And I highly recommend this book to students if they are new to the subject.
Thank you, Prof. Liberato Camilleri, for your input. We truly appreciate your help with this topic. We hope that this e-learning video has helped to further your knowledge on sampling methods in scientific research. Stay tuned for more e-learning series, more e-learning interviews about this topic, about how to conduct scientific research, and make sure to like us and subscribe to our Facebook page. Thank you.